There we go. We are now live. So I guess let's look at the GHOA assignment for this week. Okay. So earlier this week I got like the emails and saw that it's vectors, and I'm like, oh crap. I've always hated vectors. I've never really grasped the concept very well of how you can like add them onto each other and stuff, but it's making a little more sense now that I've watched the videos. I think they probably use it a lot in aviation, flight patterns, and because there's crosswinds and things, and yeah. Anyways, but so yeah, it just says to begin discussing what a vector is. Discuss how to find the component form given the magnitude and direction and vice versa, and how to do the vector operations of addition, subtraction, scalar multiplication, dot product, and angle between two vectors. So yeah, after watching those 3 videos, he goes through all of that stuff, so I think I understand that. So a vector is going to be a magnitude and a direction, right? So a distance and a direction, basically.
Okay.
So a distance and a direction, does that make sense to you? Do you have any questions there?
Sorry, I was getting stuff situated. Where are we at?
Just on the GHOA assignment, the team discussion, part 1.
So, okay. Begin by discussing what a vector is?
Mm-hmm. Yeah.
Okay.
So how do you feel there as far as what a vector is? Do you have questions or reservations with that?
What's scalar multiplication?
Yeah, it's a scalar multiplication. It's just, so when we see the vector written out, it's in that form of like the 2 numbers in the parentheses, right? So like v equals parentheses -3, comma -4, close parentheses, right? So it's in that form. The scalar multiplication is just getting 2 of those vectors and multiplying them together. So there's a formula to do that that's pretty simple, actually. Let me see where I did it here. Yeah. So it's basically the first, like if you look at the 2 vectors, it's the first 2 numbers multiplied together plus the second 2 numbers multiplied together. And that's it. Okay. Pretty simple. So like if it was x and y, it'd be x times x, y times y.
Okay.
And then you'd get 1 number from that once you're done with it. Yeah. Those videos are pretty helpful. I've decided like usually when I prepare for this, I'm like trying to run through that I don't even know, like that slideshow thingy he has, and that's kind of weird.
Mm-hmm.
So I watched the videos this time, and it's pretty straightforward. I had to pause it and go back a few times, but yeah, I would recommend just watching those when you get a chance.
Yeah.
Yeah, so scalar multiplication is just that. The dot product is oh, okay. Actually, I'm not sure about that. Multiplying two vectors together. Okay. So actually what I described there is dot product.
Oh, okay.
The first numbers multiplied together plus the second numbers multiplied together. That's dot product. Scalar multiplication is just like if you think of scaling something up, you know, you're going to like double it or triple it. And so there'll be like a scalar number that's like 3. And so you just times both of them by 3 and add them together to get one number. And that would be your scalar multiplication. Still not too difficult. Angle between the vectors is a little more complicated because normally we're given two vectors and then you have to find everything to get there. And so you have to get your, is it your resultant? Hang on. You have to get your dot product first. And then you have to get where's the other ones? Oh, yeah, and then you have to get the magnitude of each vector, which is like the U with the two lines on each side of it, right? So it's this. I'll just show you. Can't see if I'm showing you. This one. Oh, I just hit a button. Hang on. Okay. So it's this right here. So like that's the U with the two lines outside of it. And it's the square root of, is it V squared? Oh, square root of A squared plus B squared.
Oh, okay.
So that's how you find your magnitude.
Mm-hmm.
Anyways, we'll just see where we get from there. But yeah, so to find the angle between two vectors, you need both magnitudes of the vectors, you need your dot product, and then you can use another formula to get your to get the angle between the two vectors. And in the video, he like kind of shows you how to come up with the formula. Like they often show the proofs, right? But the formula is this. You should probably write this one down because it's going to be hard to remember otherwise. Can you see that okay?
It looks like theta equals arc cosine parentheses of I can't tell what's inside the parentheses.
Okay, parentheses u times v over yeah, so u times v over the magnitude of u times the magnitude of v.
Okay. I'm gonna go grab my notebook.
Yeah, okay. So that's theta equals arc cosine of parentheses u times v over the magnitude of u times the magnitude of v. And when they do the magnitude, it's like the two lines.
Yeah.
Before and after.
Absolute value.
Absolute value, yeah. So that would be your angle between the two vectors formula. I really should just write all of these in one place so I can refer back to just that one place. Instead of searching through my notebook. Okay, so part 2 says discuss what a polar coordinate is and how to plot the polar coordinate. Discuss your solutions for converting between Cartesian and polar and vice versa. Yeah, I don't know how to do that.
Yeah.
I didn't watch that video yet. Okay, well, I don't know, I'm tempted to just watch the video on that.
Okay.
So maybe you just continue with your vector part 1 and I'll get going on the polar coordinates and hopefully we can get to a point where we can just get going on this.
Okay.
Is that making sense for you?
Huh?
Is that making sense for you?
Yeah, kind of. It's just really boring.
Yeah, no arguments there. Yeah. Just gotta grind through it for now. Let me know if you have questions or anything.
Okay.
How's that coming?
I don't like these videos.
Yeah, it's easier for me to watch
It's hard
these.
to focus.
Well, at the end of the day, it doesn't help either.
How's it coming for you? Did you finish that other video up?
I've got 3 minutes left of it. 4 minutes.
Wait, how many?
4 minutes.
Oh, okay.
Yeah, it's making sense. It's just some things are like, what? Where did that come from? And you have to like think about it. So I can't just like watch it through and understand it all. I have to take it slower than that.
chief of security and feeling radical. I want to give my officers a day off on Sunday so that people can just block traffic, and then the fire breaks out, and suddenly the fire department's like, well, we can't get through because there's like 4 cars in the way. People are stupid. Yeah. But it feels good to deliver justice, though. Like knowing that, okay, they're stupid, they're entitled, spoiled, and yet here goes their chance to get it. Because honestly, tell me that if they had not come up with like a rebuke, like at least a good story, at least humble themselves. When people say, I'm sorry, like, oh, I'm apologetic, I feel like, okay, let's reduce it, right? I don't know. Probably a majority of them would get reduced, but oh, you gotta be able to expect.
Exodus 20, John 3, mission statement of BYU, Idaho.
So, oh, how much was the citation for? Do you remember? The one that you.
All right, I'm done.
I think that one was like $85.
Yes.
Are you ready?
Yeah.
How should I approach this?
Or do you still have more of the video left?
I'm done with the video. So, how are you feeling with that stuff now? Is it kind of coming together?
Yeah. Better than before, I guess.
Or? I still don't know what the Cartesian thing is. I think it just means rectangular. He refers to switching from rectangular to polar and vice versa. So I think that's really what it means when it says Cartesian. But that makes sense to me. This last video was all about that, so it's probably important to do. I didn't look at the preparation work at all, so I don't know what that number 6 is.
I would spit fire and brimstone if they came to me with crap like that.
And you'd be able to, because it's like, this might have a conversation with them, so if they try to bring specters down on your head, you get like, it's like a new hell. Honestly, shake hell. And then after a 30-minute session of you just destroying them, it's okay, your appeal has been denied. Goodbye. And that's it.
So, do people ever come to parking class and want to dispute their citations that never happened?
Okay, so let's see if we can understand what's going on number 6 in the preparation page. So on the week 8 preparation assignment, it says to discuss number 6. So let's look at it really quick.
I used to do that for like a year. Just take the steps of the process. I don't let them know because there's people who came in with their citations.
Are you there? Let's look at number 6 on the preparation page.
Okay.
Because I didn't want him to like, so it's cool.
So
Cartesian coordinates, the polar coordinates, and vice versa. Each coordinate can be described as a Cartesian coordinate, y, or a polar coordinate, or theta. Using the picture provided answer the following questions. If you were given the point x, y, write the equations to find r and theta.
yeah, so that's from that last video. It's not going to make sense until you watch that. But basically, so the rectangular coordinate is the Cartesian coordinate, right? So that's what we've been working with in the first 3 videos.
Uh-huh.
So there's the x and y coordinates, and that's what we use when we see a vector. But it can also be written differently as a polar coordinate with the r and the theta instead. And so the r stands for your radius. So it's like a circular system instead of a rectangular system. That makes sense.
Correct.
So, like, think of the unit circle,
Yeah.
and we'd put the polar coordinates on like the unit circle. So your r is your radius, and your theta is like your radians or degrees around. And so it can be written either way. And so there's equations you can use to transfer from rectangular to polar. And
was it more Sunday?
Yep, it was another Sunday. This time the dude quoted Exodus, quoted the mission statement of the
I might draw those out.
How much was that ticket for?
$85.
Yeah. I think this number 6, honestly, is just to give us a little key to refer back to
the administration of the BYU
Uh-huh.
for letting people
as we do at home.
consulting people who work on Sundays. He said he's more sorry for people who have to work on Sundays than for his citation. Yeah, seriously, it was funny. But he got denied.
I do regret it.
He quoted Exodus 20,
Uh-huh.
and then he quoted "Go and sin no more" from John. And it was great because he's like, let us all work together to make a compromise and realize we have done something wrong. And
you pretentious prick.
keep the words of our Savior and go and sin no more.
Oh my
That's what he ended it with. And I was just like, okay, Daniel has to hear this, but it's denied. Oh, I have the number for you.
Oh yes, you can text it to me. That'd be wonderful. So I can tomorrow go to the parking office and have it hopefully printed out. But
Present like 5 boards.
seriously,
This is what not to do.
they'll have a good laugh at the parking office. I'm sure of it. It was glorious. I mean, I almost regret not putting more because that's the one that you put in that this is necessary for safe.
No, that
Oh,
was
it's
the
the other one. Okay, yeah.
That's
So,
what I
okay,
just denied.
so how come it seems every single Sunday one is like at least $80?
Well, because the people who get those kind of tickets are already pretentious douchebags to begin with.
Yeah, to be honest with you, that's actually like a lot of those people, especially those who write those kinds of appeals, they will already
The ones
have
that quote scripture on
They the
us.
ones that are so righteous, quote scripture and says, "Oh, I forgive you, brethren, for giving me ticket on Sunday. You're forgiven. Right, you son." It's like, right, that will be $85, please. And
If you're gonna write an appeal, be humble. Don't try to pretend like you're some kind of lawyer in like a class 1 murder charge.
that's like we're not.
Did you guys see if it was a boy or a girl who was doing it?
I can look it up too because of the Wellness Center. I can enter I numbers and see pictures.
Nice. Yeah, I'll look him up tomorrow. So I'll let you guys know.
Because I'm always curious, because I mean, like, we just assume it's a guy, because usually guys are like,
Okay, it's actually way simpler than you expect.
yeah.
I mean,
Also, guys seem to more have cars often than
it's true. Yeah, but I think no, usually it's guys who write those kinds of appeals. I think girls.
So these are the equations.
A little more like humble. Like I noticed that's like the appeals that we actually, at least when I accept.
Can you see those?
Because it says they're just a little more like
yeah.
just humble. Like or like we had an appeal
Yeah.
where the girl was like, my friend just had an emergency in the Benson building. Her ticket.
So if you're
I had
given
to drive there and drop stuff off, for her because she needed
x and y and you want to find r,
in the A-lot, and I'm so sorry.
then you do the square root of x squared plus y squared.
Where it was an actual, like, that's a good enough
Mhm.
excuse, you're helping.
And then if you want theta,
We actually accept
you
that.
want inverse tangent of y over x.
Okay.
Then if you're given polar coordinates, and you want x, you will find, let's see, what does that say? So x equals r cosine theta,
Yeah.
and y equals r sine theta.
Yeah.
So yeah, those are just, you can use that as a key when you're transferring or when you're changing from polar to rectangular and vice versa.
Okay.
But like, yeah, that's pretty much it. Where did he use x squared or r squared? Okay. Yeah, if you watch that video, he'll explain everything. That polar coordinates video, it all makes sense
Okay.
after you go through that. For now, though, let's do a couple extension problems and get moving. So extension problem number 1 says, given 2 vectors, how would you find the resultant vector? Draw 2 vectors and the resultant vector. So, does that mean anything to you based on what you learned in the first couple videos?
Given 2 vectors, how would you find the resultant vector? Draw 2 vectors and the resultant vector.
So, you'll be given the 2 vectors, right? And those will be in either xy coordinates or r theta coordinates. And
Okay.
draw your 2 vectors. And the resultant vector is code for adding them together.
Oh, okay.
It's just the adding where you do like the x plus x, comma, y plus y, or whatever.
Okay. Yeah, I get it.
So yeah, resultant vector is adding. So let's see what number 2 says. Imagine the following scenario that involves vectors. When the prophet Joseph Smith was a young man, his father bought a farm near Palmyra, New York. As with many farms during that time, the family spent many days clearing the land to make it suitable for farming. This would have included cutting down trees and then pulling the stumps out of the ground. Sometimes this was done by hooking 2 chains around the stump and having 2 horses pull the stump out, going in different directions. Imagine that the 2 horses have an angle of 65 degrees between them. One horse is pulling with a force of 200 pounds, the other is pulling with a force of 300 pounds. The force would be the magnitude of the vector. What is the magnitude of the resultant force? What is the angle between each horse and the resultant force? So we know that the resultant force is going to be somewhere in between that angle, right?
Yeah.
Yeah. I liked that river example he gave in the video of like, if the guy is trying to, I don't know if you saw that one or not. But like if a guy's trying to swim straight across a river and the current's moving perpendicular downstream, he's not going to end up straight across the river and he's not going to end up straight downstream. He's going to end up somewhere in between, right?
Yeah.
So like instead of going straight across or straight down the river, he'll end up between the 2 vectors.
Yeah.
So this one, we're going to have to add the 2 vectors together to get a parallelogram. Find the angle between, no, we have the angle in between, right? Yeah, we do. We need the other angle though. So if we draw it out,
So the other angle is 115 degrees.
okay. Yep. Okay, and then we'll draw a triangle and just use one of the halves of the parallelogram from there. I forgot where to start, actually.
That's cool. The missionaries started in South Korea. Some got to help out with training help fans for the Olympic Games. And I guess translators for people who didn't speak Korean to like help with directions.
That's pretty cool.
That's like legit.
They say you helped out with the Olympics. That's pretty sick. I assume Annie has gone to bed. Hmm.
Okay. Did you come up with an answer?
So I found the side for B.
Yeah.
It's approximately 425.105.
I got a different number.
Oh, wait, hold on. Maybe I did it wrong. What is the magnitude of the resultant force?
So did you use the law of cosines?
Yeah, I did.
Okay. I got 332.7, which,
Oh.
I don't know, both sound reasonable. Like, yeah.
What did you use for cosine?
115 degrees.
Okay. And you
Right?
used,
Because that's the angle we found.
yeah. And you used 300 and 200 as your ANC.
Mm-hmm.
It's really weird.
So this is what my equation looked like. So b squared equals 200 squared plus 300 squared minus 2 times 200 times 300 times cosine of 115.
Yeah, that's the same one that I used.
Okay. Weird.
Let me double check my equation.
Oh, I messed up.
Oh, you did?
Yeah. Yep, I forgot to square the first two in my calculator. That'll do it, right?
Oh, okay.
Okay, that was worse. Hang on. Okay, what the heck? I got 60,000. That sounds right, doesn't it?
Huh.
I don't know what my calculator's doing, but I know that's not right.
Huh.
Oh. I see what the problem is. Well, what I'm learning from this is definitely put it in the calculator, right? 'Cause that'll screw you over. Okay, 425.1. That's what you got, right? Okay. Let's just move on to the quiz. We're running low on time. Four questions. All right. So the first question says you want to swim from one side of a river to the other side. Assume your speed is 3 miles per hour in the west direction with negligible water velocity. When you reach a certain point, you will encounter water flow with a velocity of 6.2 miles per hour in the north direction. What is your resultant speed and direction? Okay. Well, we know that's a 90-degree angle, so we don't have to search for that one. That's nice.
Wait, which one are we doing now?
Number one on the group quiz.
Oh, okay.
Yeah.
Sorry, I didn't catch that. I was grabbing a power cord.
Oh, okay. Yeah, I mean, we've got an hour and 15 minutes to do it, so I'd rather focus on
Yeah,
questions that matter.
definitely.
So,
Okay. Let's went from one side of the river to the other side. Assume your speed is 3 miles per hour in the west direction with negligible water velocity. When you reach a certain point, you'll encounter water flow with a velocity of 6.2 miles per hour in the north direction. What is your resultant speed and direction? And it helps drive pressure. From one side of the river to the other side. In the west direction. When you reach a certain point, you'll encounter water flow with a velocity of 6.2 miles an hour in the north direction. What is your resultant speed and direction?
does that make sense? How you'd set that up?
Yeah, I think I have the angle's 90 degrees, right?
Yeah.
Okay.
Yeah, so we don't have to
So-
do the quadrilateral thing to find it, which is nice. So we'll just jump straight into the law of cosines. Find our magnitude. And I'm going to put it in my calculator correctly this time.
What is your resultant speed and direction? I'm not sure what we're supposed to do with this.
So your resultant speed would be the magnitude of the new angle that it creates,
Oh,
right? So what we just did with that last question. You know how we found B?
uh-huh.
We'll do the same thing. So it's a really small picture, but so 3 miles per hour west. We don't care that it's a speed. It's 3. Ignore
Yeah.
miles per hour. So 3 this way, 6.2 this way, and
Uh-huh.
it makes like this angle across, which is our effective moving direction, right?
Oh, okay.
And so we need to figure out this distance, which is actually speed, and then also the angle between the new,
Okay.
I don't know, and like my hands are going everywhere, but
Yeah, no, I see what you're saying. So we find the magnitude first, so that's gonna be square root of a squared plus b squared.
I'm confused. I think we just jump into the law of cosines here because we're really just dealing with the triangle. right? Because we weren't given coordinates for our vector. We were just given like straight up a direction and a magnitude. So we already have the magnitude, right? So you would do square root of a squared plus b squared to find a magnitude from coordinates.
Which is.
But we already have the magnitude.
6.9.
Yeah. No, well, no. We don't need that.
Oh.
That's different. That would be getting it from coordinates, right? That would be for a single vector from coordinates. We'd use that formula to get the magnitude. But the 3 miles per hour this way is already in a magnitude form. And the 6.2 this way is already a magnitude, so we don't need that formula.
Oh.
Yeah. Because we didn't start with coordinates, right? We just started with the magnitude.
Okay.
Yeah, so we just do the law of cosines to find that angle in between, or the line in between. Okay. Mhm. Okay. Did you get that? Did you get that? How's it coming?
No, I still don't really get what's going on.
Oh, okay. Sorry.
No, it's fine. I guess today's just not a good day, so I have like no focus at all.
Gotcha. I'm sorry.
Yeah.
Okay, so I was thinking about drawing it out, but that's just still going to be hard to see. But we have those two vectors, right? 3 miles per hour this way, 6.2 this way. We want to find the angle in between. So we want the length of this part of the triangle, and we also want the direction of that triangle. Now we know this one's going straight north, this one's going straight west. And so we'll just find the alpha of this angle in order to get our new angle.
Oh.
So we have to find the side length first, which is b, using the law of cosines, because we have a side angle side effectively, right?
Uh-huh.
So it'd be 3 on the bottom, 90-degree angles, 90-degree angle, and then the 6.2 going up the side. And so using those 3 in the law of cosines, we can get the long side, which I'm calling b.
Okay.
So use the law of cosines just like we just barely did in that last question.
Yeah.
Okay.
Okay.
And I got 6.888, which we'll just add the units back on. That's in miles per hour. And then now we have all 3 sides and 1 angle, and so we need the new angle, which I'm going to call alpha. And then we just use the law of sines to get that angle from the other information.
Okay.
So, yeah, I'm going to start on 2. Let me know what you come up with.
Okay.
Band-aids, I usually don't approve of unless it's a right away thing because the point of a band-aid is to stop bleeding and to keep bacteria from getting after the point of the stab. You do need so many things. Right? To get and imagine Dan trying to tell me what guatemala is. I'm like, dude, I lived in South America with a Brazilian. I know what guatemala is. Like, yes, I know you have friends who served in Brazil, but I lived with a Brazilian.
So I got for that angle approximately 64 degrees.
That's what I got.
Okay.
Yeah, so 64.18 is what I said. I don't know how specific he wants, but
Yeah.
yeah. So, and then, so it's going to be 64 degrees further north from directly west, right?
Yeah.
So I called that, and I'm not sure if this is correct, but I said west 64.18 degrees north. Is that correct? Or do you,
64.18.
yeah, I was just being
Yeah.
specific, but so would that sound wrong to say west 64 degrees north? It seems like that's how they would term that um, when you convert that back into like a compass
Yeah.
notation.
Maybe. I'm not entirely sure.
Yeah, I don't know if it has to be north first or south first or how that works, but
Yeah.
we'll see. I'm gonna assume due west is fine. Okay, so number 2 is gonna be confusing unless you understand that last video.
Yeah.
Honestly, the next 3 are all from the last video.
Okay.
But basically, those 4 equations that we wrote down, that r equals square root of x squared plus y squared, the theta equals inverse tangent of y over x equals r cosine theta, and y
Yeah.
equals r sine theta. Those are our conversions. So you basically just use algebra to switch from one version to the other. And so we're starting with the polar equation in number 2 because we see the sine theta and the cosine theta there.
Okay.
So that's a polar equation. We want a rectangular equation. So we're going to look for the x equals r cosine theta and the y equals r sine theta. And so basically we just want to do algebra with that so that we get r sine theta somewhere and r cosine theta, because that's one side of the equal sign there on these functions, right?
Okay.
And so if you get r cosine theta somewhere, you can basically just substitute that for x. And if you get r sine theta somewhere, you can substitute that for y. And that's all there is to it. But so in this one, we have 3 sine theta on the bottom there. We need r directly next to it. So we have to like do algebra to get r sine theta somewhere and r cosine theta somewhere, and then just transfer the x and y in. Does that kind of make sense?
Yeah.
It's just substitution.
Yeah. Okay.
Is that kind of making sense?
A little bit. I'm just
So on
trying
that
to work
one,
it out right now.
yeah. So on that one, you just multiply the denominator to the other side, distribute the r, and then basically at that point you'll have 3r sine theta minus 7r cosine theta equals 10.
Oh.
And then you just substitute y in for the r sine theta, and you substitute x in for the r cosine theta, and end up with 3y minus 7x equals 10. And that's your new equation. It probably sounds complicated when I say it out loud, but it's actually really simple. And then number 3, we'll be going from polar to rectangular, so we'll use those other two equations. Crap, I'm a little confused on this one. Oh, never mind. Tangent theta equals y over x. Okay. Well, that one's a little more confusing, but hang on. We're okay. Are you working on that, or have you kind of just called it?
I'm trying to work on it. I'm just having a whole lot of nothing.
Yeah. Well, I got number 3, and
Okay.
it was pretty simple once I realized what to do, but it was a little weird until that point.
Yeah.
Are you on 3 or are you on 2?
I'm on 3.
Okay, so we have that equation r equals square root of x squared plus y squared, right? And so we have the x squared plus y squared there already. So we can just square root that. We can square root both sides, and then we effectively have the whole right side of that equation. So we can substitute r in on the left side. So it would turn into r equals 3y over x, right? Once we square root both sides.
Oh. Okay.
Yeah.
I was like, I only got to x plus y equals 3y over x.
Yeah.
So I was just like, I don't know what to do at this point.
Yeah.
But that makes sense.
Yeah. So we substitute the r in, we square root the right side, so it's 3y over x. And then so that equation theta equals inverse tangent of y over x is equivalent to the equation tangent theta equals y over x. And so we have y over x, and we just substitute tangent theta in for that. And so our final equation is r equals 3 tangent theta. And that's it.
Okay.
It's really not that bad. It's just really weird to look at until you understand what's going on.
Yeah. I'm like freaking dead.
I really like his videos. I think he gives it to you straight. And he shows you all the examples you really need to know. Shows you all the formulas you need to know. So I just watched the videos, wrote down every formula, circled the ones in red that I thought were going to be useful. And now I'm just referring back to those, and it works. It's working out pretty okay. All right, number 4. This one's weird. Graph the polar coordinate, so like on the unit circle.
Okay.
An ordered pair in polar coordinates names a single point. However, the coordinate is not unique, so we need to name 2 other polar coordinates that are located in the same place. I'm going to do a giant graph here.
want to date with her. She says, no, I'm done. She asks, if you don't want to date, have fun, ask her out again. She does. If she didn't have fun, she won't say no. Or if she didn't have fun, she won't say yes to a second. Let's not hesitate.
Okay, so the 4 is our R. That's our radius. So if we start from the origin in the middle, it's going to go out 4. In the unit circle, it's always 1, right? This time it's going to be 4, but basically nothing changes. You just note that it's 4 units instead of 1. And then our theta is 4 pi over 3. So that ends up being where? In the 3rd quadrant, right? So that's okay, so this is the vector I got. So I just drew rings to represent a unit of 1 per ring. And so my radius is 4. And then the angle is there, ends up being there in the unit circle.
Okay.
And so this point represents that point on the unit circle. And we need 2 other polar coordinates that end up in the same place. So to end up in the same place, it's going to have to be a radius of 4.
Mm-hmm.
Like there's no way around that, but your angle can change, right? So it can be 4 pi over 3, or it can be what would that be? Negative 2 pi over 3. So I'm just going to do that. 4 and then negative 2 pi over 3, because that ends up literally in the same place on the unit circle.
Mm-hmm.
And then another thing we can do is we can go, instead of a radius of 4, we can do a radius of negative 4, and then just choose the point on the exact opposite side of the unit circle. So, so negative 4 and pi over 3. And that's it.
Okay.
So, yeah. That last video was definitely the most helpful for this quiz. But I don't know. It's all kind of I don't know. I'm sure we'll use the rest of it on the homework.
Yeah.
Well, I feel pretty good about this. Yeah, honestly, I just suggest finding a time to watch the videos and note all the equations and how he does things, and it's really not bad.
Okay.
Okay, well, I'll get this stuff turned in and call it a night, huh?
All right. Sounds good.
Well, I hope the rest of your night goes better and tomorrow as well.
Thanks. I'm
Yeah.
gonna need it.
Well, keep it up. Don't get down on yourself, and don't. I don't know. I mean,
Okay.
I wish I could do more to help for you, but
That's all good, man.
yeah. All right. Well, have a good night.
Yeah, you too.
I'll see ya.
See ya.